Hi, good morning. Welcome back to our discussion on hurricanes. So, yesterday we kind of cleared up some terminology, the difference between tropical depression, tropical storm, hurricane, also between watches and warnings. And we even learned that typhoons, cyclones, and hurricanes are the exact same storm, just depends on where you live. I really appreciated a lot of you sharing information with me yesterday. So, we talked a lot about how the storms are named and about names becoming retired if the storm is extremely deadly or extremely costly. And Izzy shared information with us on the names that have been retired since the 1950s. So I thought that was pretty cool. I had fun kind of going through and seeing which ones I remembered from being a kid and from being an adult. I obviously remember a lot more as an adult than as a kid. And then Emmy shared with us about a storm that wasn't on the list because that data was from before this storm happened. So she reminded us of Hurricane Harvey that had a great impact on Texas, and I included some links on that hurricane. And then I also threw out there not to forget about some of our other more recent storms, Hurricane Maria, which was especially devastating for Puerto Rico, and Hurricane Dorian, which we talked about at the beginning of this year and its effects on Florida. So I'm sure this summer you're going to hear a lot about hurricanes, and maybe some from this summer will be record breaking and destroy that list even further. So it'd be interesting to see how this summer plays out. But now that we kind of talked about the facts and what a hurricane is and cleared up some of the terminology and how it's named and how it's measured, we need to talk about how it's formed. And a hurricane's formation is rather complicated. So I figured it was best if I talk about it first, and then I'm going to include a couple of videos for you to watch that I think do an excellent job of taking this complicated topic and breaking it down. So the first thing we'll do is talk about what is needed for a hurricane to form. So you need three things. You need warm air, you need moist air, and you need wind. So where are these three things coming from? The warm, moist air is going to come from warm ocean waters. So we have to think about where on Earth is the ocean going to be warmest. And that's going to be in the waters near the equator, which is why certain locations are more likely to be impacted by a hurricane than others. So when you watch the videos, it will show you in the video the specific parts of our ocean, our Atlantic Ocean, where hurricanes can form. So it's going to be more of the southern Atlantic, which makes sense because that water is going to be warmer, and the Gulf of Mexico, which is a body of water near the southern portion of our country, states like Florida and Alabama and Mississippi and North Carolina, which is why we tend to hear those areas impacted. The Indian Ocean because of its geographical location, and the South Pacific Ocean. You're not going to hear about any storms forming in the North Atlantic or any storms forming in the Arctic Ocean because it doesn't have what a hurricane needs, that warm, moist air. Now, winds are also needed. And it's interesting that a lot of the winds that fuel the hurricanes in the Atlantic actually come from Africa and travel across the Atlantic Ocean to our eastern seaboard and our south coast. So it's interesting to think that something from across our ocean can impact our weather, but it can. So if we talk in terms of formation, again, step one, we need warm ocean water forming near the equator. Wind is going to be a key factor, and if we're talking specifically of the Atlantic Ocean, because those are the ones we have to worry about impacting us, we're concentrating on winds that usually form near off the coast of Africa, the west coast of Africa, and travel across the Atlantic Ocean toward our area. Now, we should remember from density discussions what happens to warm air. As air gets warm, remember the molecules get excited and they start moving really fast and they move far apart. And we talked about like if you're hot, you don't want anyone near you, you're like, get away from me. So as air gets warm, it's going to become less dense. And as it becomes less dense, it rises. Now, not only does this air warm, but it's also moist because it's picking up the moisture from the water that it's forming over. So this warm, moist, less dense air is going to start to rise up in the atmosphere. And what that leaves beneath it, so as the warm air rises, it leaves a low pressure area near the surface. Low pressure is what's needed for a storm to happen, any kind of storm. So anytime it's raining out or there's a tornado or a thunderstorm or a hurricane, you'll notice on the weather they'll talk about a low pressure area moving in. Low pressure signals stormy weather. The lower the pressure, the more severe the storm is going to be. So that's something interesting to think about. So as that warm, moist air rises, it leaves low pressure behind, and it kind of makes sense because if there's less air down there, then it's going to be less pressure, less force pushing down. So warm air rises, low pressure area is formed. Now you have this empty space. What's going to happen? Air from somewhere else is going to rush in to fill that place, okay? And that's going to be higher pressure air. But as that air rushes in, if the water is warm enough, it's going to continue to evaporate and to rise up in the atmosphere, so it keeps feeding that storm. So we had warm, moist air here, empty space here. Air fills in, it warms up, it joins up here, and that's going to keep happening. As long as the water is warm enough, it's like fuel for the fire. It's fuel for the storm. So that air is just going to keep rushing in, keep getting warmed up, and keep rising. Now, as the air rises, keep in mind what happens. Now that warm, moist air is going to start to cool off. Because as you move further away, it's going to get cooler. I shouldn't say further away. As you move higher up in the atmosphere, it's going to get cool. Once it cools off, now that water vapor condenses and forms water droplets. Those water droplets are what create the clouds in the atmosphere. So we got these clouds starting to form. Because the earth rotates or spins, those clouds are also going to start to spin. And you have these clusters of thunderstorm clouds. And they're going to start to join together and spin around this eye, okay? And the more heat and moisture, the bigger the storm is going to get. As the storm starts to rotate faster and faster, you'll get a well-defined eye, and you'll get all those storm clouds gathering together, spinning around it. And we'll talk about the different parts of the hurricane in a minute. Once the wind speeds in that storm reach 74 miles per hour or more, we know it's classified as a hurricane. That storm that we just talked about in its formation will be given a name once it's 39 miles per hour or more, because it'll be a tropical storm and they'll start to track it and watch for its location. Hurricanes are a large storm, hundreds of miles wide in some cases. And one of the videos I included yesterday gave you the five biggest storms in terms of size. Hurricane Sandy, which actually impacted this area, was number one on that list. And the strength of the storm, the wind speed, has to do with how much warm air and moisture is being fed into that storm. The more heat, the more moisture, the stronger the storm is going to get, the stronger the wind speed. The lower the pressure, the bigger the storm in terms of wind speed is going to get. So that's kind of interesting. As the storm moves, a hurricane moves slowly, which that's probably the only good news about the hurricane, because that allows meteorologists to track it. And if they can track a storm, they can give people warnings so they can prepare, whether that means evacuating or taking special precautions to board up their property. So that helps prevent some of the loss of life, because it is a storm that can be tracked. It's also a storm where the track can change quickly. And there's a couple of things that can weaken a storm. If a storm, like a hurricane, goes over cold water, that's going to weaken it, because remember what a hurricane means, warm, moist air. So as soon as it moves over colder water, it's going to lose its fuel or lose its strength. It's almost like a car running out of gas. This is why we in northern New England don't tend to get large hurricanes, category 4, category 5. Because by the time the hurricane moves up the eastern coast to the North Atlantic, the waters are cool and it loses its energy. The other reason a hurricane loses its energy? It is when it hits land. Again, it needs warm, moist air. It's not going to pick up moisture from land. It's going to pick up moisture from water. So when it goes over land, it weakens. Another reason why a lot of the storms that form, let's say in North Carolina or Florida, or off the coast of those states, don't impact us severely. Because by the time they hit those states, they lose strength. And a lot of times the hurricane will move over land that way. And by the time they reach us, maybe we get some rain and some leftover wind, which was the case with Hurricane Dorian. Katrina was an interesting storm. Katrina formed in the Gulf of Mexico. And Katrina, during its formation, was a Category 3, which is a pretty significant storm. It hit certain states, Alabama, Mississippi, hit them pretty hard and lost strength. But then it went back out into the Gulf of Mexico and stalled there for a few days, gaining more strength. So when it hit Louisiana, it was bigger than when it originally started. So again, that just gives you an idea of how that warm, moist air feeds and fuels that storm. It also should make sense why we have hurricane seasons. We don't see hurricanes in December, January, February, March, April. The waters in the Atlantic are too cold. So we only start to see them as the waters warm up. And every ocean has a different hurricane season based on their seasonal temperatures. And I'm going to have you look that up today. I'm not going to tell you. You're going to look it up. So following this video, you're going to have 2 videos that go over the hurricane formation. I'm also going to include a diagram with the parts of the storm, which I'm going to go over right now, and just a question to throw out there if you're interested in doing a little more research on your own. So there's 3 parts to a storm if you see a diagram of a storm, or if you see images of a storm from space, like that video I included yesterday, which I love looking at images of hurricanes from space. I think it's cool. You have the eye wall, and you have the rain bands. The eye wall is the center of the storm. Everything kind of rotates around that eye wall. What's also interesting is the eye is the calmest part of the storm. When an eye passes over an area, even in the middle of a hurricane, all of a sudden the rain stops, the wind slows down, and the sun comes out. And sometimes that can be the most dangerous part of the storm because people assume that it's over, but it's being followed by the heaviest part of the storm. So right when the eye is over you, the heaviest part is coming next, and that's the eye wall. So this is the part of the storm that has the strongest winds and rains. The winds in that eye wall can be up to 200 miles per hour. Again, it depends on the category. And those are those thunderstorm clouds that have gathered and are now spinning around that eye of that storm. And then you have the rain bands, which are just what it sounds like. Those are clouds that continue to spin out. They make the storm bigger, and those are what's going to bring the heavy torrential rains associated with a hurricane. Now, it's usually not the heavy winds or the heavy rains that cause the most loss of life. Don't get me wrong, it can cause a lot of damage and it can cause some severe effects and loss of life, but the biggest loss of life usually comes from the storm surge, when the water level rises and it has nowhere to go but inland. Next week, I'm going to put a video up about Hurricane Sandy because that's probably the biggest one in recent history that affected the Northeast. And what was interesting about that storm is it took place during a high tide, an astronomical high tide, which meant it was also a full moon. So you had the sun and the moon's gravity pulling on the water, so the water level was already higher than normal, and it was high tide. Then you had the storm surge from the hurricane, so places saw massive flooding. Katrina, most of the loss of life was from the flooding as well. When the winds of Katrina hit New Orleans, it broke the dams, holding back the water. Now, New Orleans has an interesting geography. There are lakes surrounding it, and these dams hold back the water, and it's also below sea level. So they say it's like a fishbowl. So when the dams broke, all the water filled in and put New Orleans mostly underwater. That's another video I'll share with you next week. Harvey, which Emmy mentioned to us, the most devastating part about that storm was the torrential rains from those rain bands that caused some severe flooding. So all these interesting things to think about when we think about the most powerful storms. They're considered the most powerful storms on Earth. They're very large, So they cover a large area, unlike a tornado, which has a narrow path, which could go down one side of the street and destroy all the homes and leave the other side of the street untouched. A tornado's path is much, much too wide for that. Not a tornado's path, a hurricane's path is much, much too wide, where a tornado's path is narrow. Tornadoes also last for a matter of seconds. I think the longest tornado on record was 3 minutes. Hurricanes linger for several days and hit multiple places. So interesting to think about hurricanes being some of the most powerful storms on Earth. I hope you learned some more. And feel free also to share updates if you found any updates on the India hurricane or typhoon or cyclone. I think they call it a cyclone in India. I would love to hear the updates. It makes my day. So have a great day. Keep learning. Today is going to be gorgeous. So get outside, enjoy the day. I'm ready to enjoy my day. I'm ready to get out and get my jog on. So have a wonderful day. Talk to you soon.